Earthquakes, volcanoes, and tsunamis. Earthquake, volcanoes, and tsunamis. Focus question. What causes earthquakes, volcanic eruptions, and tsunamis, and how are these causes connected to one another? Introduction. We usually think of the ground and the ocean as stable and peaceful things. The ground lies quietly beneath our feet, and the ocean laps gently against the shore. But forces deep within the earth can suddenly be unleashed, destroying the peacefulness. These forces cause the violent shaking of earthquakes, the eruptions of ash, gases, and hot rocks of volcanoes, and the huge waves of tsunamis. In this book, you will read about these amazing events and the underlying forces that cause them. Deep within the earth. Beneath the soil, rock, and water on the surface of our planet, the earth is constantly changing. The top layer of earth is made of giant pieces of rock like the pieces of a puzzle. These giant pieces of rock called tectonic plates make up the continents and ocean floors. There are 14 major tectonic plates and many smaller plates that make up the outermost layer of the Earth's crust. These plates are around 100 kilometer, 60 miles thick. Where the edges of the plates come together, there are often cracks and gaps called faults. Most of the world's earthquakes and volcanic activity occur near the faults along the edges of the tectonic plates. Underneath the plates, the earth is very hot with normal temperature of 700 degrees Celsius to 1,300 degrees Celsius, 1,252 degrees Fahrenheit to 2,352 degrees Fahrenheit. It is so hot that rock melts into liquid magma. The plates float on top of the underlying magma. The magma is always moving, and as it moves, it carries the plates around with it. Tectonic plates normally move at speeds of 0.65 to 8.50 centimeters, 0.25 to 3.35 inches per year. At the edges of the moving plates, three different things can happen. If the plates are moving against each other, one plate slides over or under the other plate, Fig 1. If the plates are moving past each other, the edges of the plates grind together, Fig 2. And if the plates are moving apart, they make a gap where magma seeps out, Fig 3. Earthquakes, terrible trembling. The edges of the tectonic plates usually move very slowly, but sometimes large pieces of the plates get caught on each other. The plates keep trying to move, but these large blocks of rock hold them back. The pressure and energy build up. Then suddenly the rocks give away, releasing all the pressure and energy. The plates jerk forward and the ground shakes. For above, people feel an earthquake. Some earthquakes are small and harmless. In a small earthquake, the ground shakes a little, causing some hanging objects to swing. Tree branches sway as if there were a gentle breeze. Some earthquakes are so small that we do not even notice them. Small earthquakes happen very often in certain parts of the world, like California and Alaska in the United States, as well as in other countries like Chile, Greece, and Japan, but sometimes the shaking is so strong that buildings crumble, bridges collapse, and large cracks open in the ground. We measure the strength of earthquakes on an instrument called a seismograph. Each earthquake is given a number from the Richter scale, depending on its strength. You can look at the chart on the next page to learn what the different strengths of earthquakes feel like. For each number on the Richter scale, an earthquake is 10 times as strong as the previous number. A 6.0 earthquake is 10 times as strong as a 5.0 earthquake. It is 100 times as strong as a 4.0 earthquakes. The largest earthquake ever recorded measured 9.5 on the Richter scale. It occurred on the coast of Chile in South America. Scientists are still learning about these dangerous events. One day, they may be able to warn people before earthquakes occur. The Richter scale. People cannot feel the earthquake, only sensitive instruments can detect it. People usually do not feel it. Some people in tall buildings may sense a silent swaying. Many people near the origin of the earthquake notice the shaking. No damage occurs. People at the origin of the quake definitely feel it. Hanging objects sway. Water sloshes in swimming pools. Some weak buildings may be damaged. Felt over a wider area, usually lots of damage to weak buildings at and around the center. Some damage to strong buildings. Lots of damage to weak buildings. Some damage to strong buildings. Damage can spread over 160 kilometers, 100 miles. A very major earthquake. Most buildings at the center are destroyed. Cracks form in the earth. Underground pipes break. Large landslides can occur. Buildings and bridges destroyed. Large cracks appear in the ground. Large landslides. The ground appears to move in waves. Entire river may move. Objects can be thrown into the air. Total destruction of buildings and other structures. A major earthquake struck the San Francisco Bay Area of California on October 17, 1989. Known as the Loma Prieta earthquake, it measured 6.9 to 7.1 magnitude on the Richter scale. Although the earthquake lasted only 15 seconds, it killed more than 60 people and injured several thousand more. The earthquake also caused an estimated $6 billion in damage to buildings, roads, bridges, and other property. This was the largest earthquake to occur on the San Andreas Fault in California since 1906, when an even more powerful earthquake and the fires that followed it destroyed much of the city of San Francisco. Volcanoes, enormous explosions. A volcano occurs wherever magma from deep inside the earth comes out through a crack in the surface. Volcanoes usually happen near the edge of the tectonic plates, where there are many cracks and thin spots where the magma can leak out. When the magma pours onto the surface, it hardens, often peeling up into a mountain. Sometimes the liquid rock flows peacefully out across the land. Many volcanoes on the Hawaiian Islands act like these. But sometimes in very powerful volcanoes, the hot magma cools before it gets to the surface. It turns into a solid piece of rock, plugging up the crack or hole where it had been seeping out. It acts like a plug in a bottle. The magma continues to push upward. Hot gases in the magma press against the plug. The pressure gets greater and greater. Suddenly, the volcano explodes. Huge chunks of rock burst from the volcano. Entire mountain slide can be ripped away. Hot, poisonous gas, ash, and melted rock shoot into the sky. The volcano erupts with unbelievable power. Many dangerous and destructive things happen during volcanic eruptions. When mountains explode, they send tons of rock rolling down their sides. These falling rocks are called landslides. Landslides can bury whole cities. They can block rivers, causing floods. Clouds of ash and dust rise into the air during volcanic eruptions. The ash falls to the ground like snow. The ash is so heavy that the roofs of houses can collapse under its weight. And ash can spread all over the world. Large ash clouds can even block out sunlight. The temperature of the entire earth can cool down after a large volcanic eruption. A volcano can cause an explosion of extremely hot, poisonous gases. The explosion can be so powerful that it knocks over entire forests, and so hot that it starts destructive fires. Some large volcanoes have snow and ice on top. The hot gases melt all the snow and ice at once, and the water rushes down the mountain. This large dirt-filled flood is called a mudslide. A mudslide is like a liquid landslide. Scientists are not yet able to predict when earthquakes will happen, but fortunately they have gotten very good at predicting when a large volcano is about to erupt. In 1991, scientists warned the people living around the volcano in the country of the Philippines that the volcano was about to erupt. Many people left the area and found safety before the huge volcano erupted. A very large volcano called Mount St. Helens erupted in Washington state on 1980. Mount St. Helens is part of a chain of volcanic mountains in the Cascade Mountain Range that runs throughout the Pacific Northwest, where the Grande Fuca tectonic plate meets a North American plate. The explosive power of the volcanic eruption completely destroyed the upper portions of the mountain and flattened all the trees in the forests for miles around. The resulting cloud of ash released into the atmosphere darkened the sky over a large part of the United States. The volcanic ash fell like snow for several hours in 10 states following the eruptions. The Mount St. Helens eruption was the deadliest in U.S. history, resulting in the death of 57 people. It also destroyed homes, bridges, railroads, and highways. Tsunamis, wild waves. Tsunamis are huge waves caused by earthquakes or volcanoes. They used to be called tidal waves, but the word tidal means sometimes to do with the ocean's normal tides. And tsunamis have nothing to do with the tides. Tsunamis can be as high as a football field is long. They are the largest waves in the world. The edges of the plates where earthquakes and volcanoes often occur usually lie near the edges of the oceans. The shaking of an earthquake of the explosion of a volcano can cause large landslides. Entire hills can collapse, and sometimes they fall into the sea and make huge waves. Earthquakes and volcanoes can also be found under the sea. Underwater earthquakes cause the seafloor to move violently. Undersea volcanoes cause explosions under the water. Both of these events create huge waves that spread across the surface of the ocean. Tsunamis speed outward away from their source in all directions. A tsunami can cross an entire ocean. Tsunamis travel extremely fast, up to 320 kilometers per hour, 200 meters per hour. In the open ocean, tsunamis may not be very high above the surface of the water, but they are very deep. As tsunamis approach land and move into shallow water, the elevated ocean floor pushes the waves upward. The wave shows to about 70 kilometers per hour, 49 meters per hour, and the ocean floor lifts it higher and higher. By the time a tsunami reaches land, it is tall enough to destroy almost anything in its path. The largest tsunami ever recorded happened when an earthquake triggered a landslide in a small Alaskan bay in 1958. The landslide splashed water 524 meters, 1,720 feet into the air and sent a giant tsunami racing down the bay. Most tsunamis are not that big. They are usually between 1 and 10 stories high when they reach the shore. That might not sound very high, but it is hard to imagine the power of this much moving water. Most coastal towns and villages are much less than 30 meters, 100 feet above the sea. Even a small tsunami can destroy houses, streets, and entire towns. A tsunami caused by a volcano in Indonesia killed 36,000 people in 1883. More recently, a large tsunami struck the countries bordering the Indian Ocean in 2004. The Indian Ocean tsunami began when an earthquake occurred on the ocean floor near the western coast of Indonesia. The earthquake caused a ring of tsunami waves to speed outward from the point of origin, crossing hundreds and even thousands of kilometers of open ocean to strike countries far away. More than 225,000 in 11 countries bordering the Indian Ocean were killed by the resulting waves. Satellite data analyzed after the tragedy showed that the height of the tsunami wave in the deep ocean was only 60 centimeters, 2 feet. When the waves reached the shallow waters near the beaches, however, they often grew to reach over 24 meters, 78 feet tall. As a result of the 2004 Indian Ocean tsunami, many countries are now working together to create a tsunami warning system for that part of the world. Like volcanoes, tsunamis are becoming easier to predict. They usually do not hit the shore until a few minutes to a few hours after the earthquake or volcano that causes them. Scientists have instruments that detect volcanoes and earthquakes. When a large eruption or earthquake happens, scientists have time to warn people that a tsunami may be coming. Unfortunately, the system cannot warn people in time to save their homes or belongings, but they do have time to save their lives, which is the most important thing. Conclusion: our quiet planet occasionally turns violent. During a large earthquake, the ground shakes, destroying homes and property. In an explosive volcanic eruptions, liquid rock, poisonous gases, ash, and landslides can bury cities, and tsunamis can cost billions of dollars in damage along coastlines. Scientists are trying to learn as much as they can about these violent events. As they learn more, scientists can predict the volcanoes, earthquakes, and tsunamis in order to save